All right, we're back and we're going to cover the dual process model. So there are different ways of thinking, of processing information. Type 1 method of processing information is fast, it's automatic, it relies really heavily on heuristics. Type 2 is slower, it's more effortful, it's more likely to be correct, right? But which one do you think we use more often? Type 1. The kinds of activities that require type 2, a lot of times we kind of like to avoid because it's slower, it's more effortful. We don't want to put effort into thinking about things. We want to be able to make judgments and move on. And so we do a lot of type 1 processing. I'm going to say another thing about that before I move on to reasoning. So I already alluded to this when we were talking about availability heuristic. One of the reasons why we rely on type 1 so often is that we usually are right. Like, actually, I should put it this way. We usually are either right or don't find out that we were wrong. And so why wouldn't we just try to be as fast as we can, rely as much as we can on just automatic thinking and move on with our lives? Right? Why wouldn't we do that? And so we see that a lot, right? We only slow down and think in an effortful way when the situation demands it, when maybe there's higher stakes in being right or wrong. But we can get away with type 1 reasoning so much because we oftentimes don't even know whether we were right or wrong. Let's say you're walking down the street and you see another person who you don't know, and you're approaching, you're walking in opposite directions. So you're coming closer to each other and you see the person and they look in a certain way, which then invokes those illusory correlations of other things that you assume go along with a person who looks like that. Maybe it's their style of dress, maybe, whatever it is. And so you've got your little set of, expectations or beliefs about what this person must be like. And then you pass them and you never see them again. That's how a lot of information is processed, isn't it? That you never even find out whether you're right or wrong. And so, of course, we're going to use a lot of automatic, fast, heuristic kind of thinking, right? Because a lot of the times we don't know the outcome, or we consider ourselves correct. I mean, we maybe weren't perfectly correct, but we're like, you know what, I was close enough. That was good enough. That solution that I came to, or that judgment that I made, was close enough. Yeah, I may have gotten a detail wrong, but it's good enough. And so we're not that motivated to use the slower, more effortful thinking. We'll talk about that more when we get to problem solving. So let's talk about reasoning. There's reasoning that's called deductive. Deductive reasoning is sometimes called propositional reasoning. So some of you who have had philosophy might have heard some of these terms. What I wanted to talk about is categorical syllogisms. These syllogisms are going to refer to either some or all or none in the syllogism, and you're supposed to use your logic to determine whether the proposition is true or false. Let's do an example, because I don't know about you, I'm not a philosopher, and so this sounds confusing to me. So a categorical syllogism will say something like, all A's are B's. So let's give an example. All B's are C's, and then all A's are C's. Okay, so let's give an example. So in the place of the A, we're going to say Seattleites, and then in place of the B, we're going to say drink coffee. So all Seattleites drink coffee. So all A's are B's. So all Seattleites drink coffee. Okay. So now all B's are C's. So all coffee drinkers are, in this case, irritable. Okay, so we've got all B's, coffee drinkers, are C, irritable. Okay, so logical syllogism, a categorical syllogism, says that, well, if all A's are B's and all B's are C's, then all A's must be C's, right? Because everything's equivalent. So the logic would be that, therefore, all Seattleites, all A's, are irritable, are C, right? So we see something like this, all Seattleites drink coffee. Okay, well, we already know that all Seattleites don't drink coffee. And then all coffee drinkers are, oh, that's not true either, right? Some coffee drinkers aren't irritable. That's an exaggeration, right? Therefore, all Seattleites are irritable. That just sounds wrong, doesn't it? This whole thing sounds wrong. So a lot of times we would rather use some. We feel better about some as the categorical syllogism. So some A's are B's. Some Seattleites drink coffee. That's true. Some B's are C's. Some coffee drinkers are irritable. That's true. Some A's are C's. Therefore, some Seattleites are irritable. Okay, yeah, that makes sense. Okay, that one sounds better, doesn't it? That seems more logical. That seems more accurate to use some. We're going to play one more time. I think we're going to play one more time. There we go. So here we have some A's are B's. Okay, some dogs are Seattleites. That's true. Some dogs live in Seattle. That's true. Okay. Some B's are C's. So some Seattleites are cats. Okay, that's true. There are cats that live in Seattle. Okay. Therefore, some A's are C's. Therefore, some dogs are cats. Okay, now we see the problem with the some type of categorical syllogism. While it sounded better when we were talking about Seattleites and coffee drinkers and irritability, that sounded better. When you put in you substitute other things, you suddenly realize that that kind of logic is actually faulty. That you actually are more right if you say all or none than you are if you say some, because you can get into these weird things, right? Where now the logical conclusion is that some dogs are cats. So the point of putting this in here in the middle of our chapter, in the middle of this lecture about deductive reasoning and this kind of categorical syllogisms, is to point out that even when we deliberately attempt to apply logic in this sort of philosophical use of the term logic, that if we apply the rules consistently to things that make us feel better about the judgments that we're making, sometimes the reasoning falls apart, the logic falls apart. And so this is one of the things that kind of can interfere with good judgments, right? When we're trying to make good judgments, we make mistakes because we're trying to be accurate in one certain way that is not like following the rules of accuracy. Okay, I'm going to have this this TED Talk in the playlist so that you can hear like the logic of like AI basically. Can machines think like humans? And AI is on the top of everybody's mind lately since ChatGPT came along and can produce reasonable sounding written responses to things. They're not the greatest. It sounds like ChatGPT wrote things that ChatGPT wrote. But this TED Talk does a good job of kind of covering some of the stumbling blocks and difficulties that machine logic runs into, because the machine logic will stick with the rules where we will not. And so it causes them to make different kinds of judgments. All right, so I'll let you watch that later. So, whoops, I went too fast on that. So we have the deductive reasoning that I just covered, and then we also have inductive reasoning. And that's where machines really fall apart. When they're trying to think like humans, is on the inductive side. Inductive reasoning is the kind of reasoning that is based on experience, is based on your knowledge of what's likely to happen, which sounds a whole lot like a heuristic, right? Inductive reasoning is like heuristic reasoning. Now, of course, it can lead to errors, just like I already talked about with representativeness and availability, right? That your experience can cause you to jump to conclusions. Your expectation of what is likely to happen in a circumstance that you're experiencing right now based on what you've experienced in situations like this can be faulty, right? You can make mistakes when you use experience and knowledge of what's likely. But it serves us well. The more experience you have, the greater knowledge you have about what is likely, the more likely you are to be right. So it tends to serve us well. Inductive reasoning tends to serve us really well. So what I wanted to kind of tie deductive and inductive back to is something that we talked about way at the beginning of this class, the top-down processing versus bottom-up processing. And what we find is that deductive reasoning is bottom-up processing, where we start with the elements and try and come to a conclusion. Inductive reasoning is where we use what we already know to try and impose a solution to the current problem, to make a judgment, in this current circumstance. So I thought it would be fun to kind of just tie these new concepts back to something that you learned, weeks and weeks ago, bottom up processing versus top down. So inductive is top down, deductive is bottom up. All right, so let's try and solve a little game here. So you have 4 cards. The one on the left has a white triangle next to a white circle, next to a black triangle, next to a black circle. Okay. Whoops, my animation is off. Sorry about that. I'm going to pause you for a second. All right. So our hypothesis is that if there is a black triangle on one side, there is a white circle on the other. Okay. Now, the rules for how these cards were created is that you're seeing one side of each of these 4 cards. On the flip side is the other shape. Okay, so on the back of each of these triangles, we know there's a circle. The question is, what color is the circle? It's either white or it's black. And on the back of the circles is guaranteed a triangle, but what we don't know is whether it's black or it's white. Okay, so when we ask the question, or we state the hypothesis, if there's a black triangle on one side, there is a white circle on the other, there is a very concrete, knowable way to test that hypothesis. So which card or cards must you flip over in order to test the hypothesis? Now, I would like to encourage you to say something less than 4, because certainly we could answer the question if we flip over all 4, but we're going to try not to flip all 4. We want to do as few flips as we can and answer the question. So if there's a black triangle on one side, there is a white circle on the other. All right, and I think these are in the wrong place too. Hold on a second. All right, so which card or cards must you flip in order to test a hypothesis? So you want to do as few as you possibly can. So hopefully you want to play along with me and you're thinking your thoughts about which one you would flip or which ones you would flip. I'm going to start with the ones that students in class have historically said that they want to flip. So usually what they want to do is start with the black triangle, and which is a pretty good place to start, right? If you start with the black triangle, there's the chance that you can flip it over, find a white circle on the other side and say, see, the hypothesis is supported. Or you might flip it over and you find a black circle on the back and you can say, see, the hypothesis is refuted, right? So it has that possibility of supporting or refuting. The other thing that they want to flip over is the white circle. And the white circle would support the hypothesis. If I flip over that white circle and I find a black triangle, I say, see, the hypothesis is supported. I've got a black triangle with a white circle on the back. But what would it do to the hypothesis if we flipped over that white circle and we found a white triangle? What would that do to the hypothesis? Honestly, nothing. The hypothesis doesn't say anything about what has to be on the other side of a white circle. It says what has to be on the other side of a black triangle. So that's a kind of that logical syllogism kind of thing that we were talking about earlier, where we kind of automatically think that if there's a black triangle on one side, there's a white circle on the other, kind of implies that that means if there's a white circle on one side, there has to be a black triangle on the other. But that's not what the hypothesis says. So the white circle really can only support our hypothesis. It can't do anything else to the hypothesis. So is there anything else we should flip? Well, the white triangle is not much use, because if you find a white circle on the back, so what? If you find a black circle on the back, so what? Doesn't matter. So that really doesn't do anything for our hypothesis. Most of my students, and according to research, about 10% of people who take a test like this will say anything about the black circle. Most people kind of just ignore the black circle. Why would I look at the black circle? All the black circle can do for us is refute the hypothesis. If we flip over this black circle and we find a black triangle, we know that the hypothesis is wrong, because we've got a black triangle with something other than a white circle on the other side. But people are not really that interested in flipping over the black circle. About 10% of people are willing to flip over the black circle. So if we were in class live, I'd say, what principle is this illustrating? So you can think about it for yourself for a second. What principle is this illustrating? And what it's illustrating is the confirmation bias. Here we have something that you cannot possibly care about, right? As a person who's watching this video, you did not come in here caring about what's on the back of a black triangle at all, right? Like, it's not something that you're invested in. Yet you still are not interested in falsifying the hypothesis that if there's a black triangle on one side, there's a white circle on the other. You're just not really interested in refuting that hypothesis. Instead, you probably were attracted to the white circle. After the black triangle, which makes sense. The black triangle makes sense. Honestly, if I was doing research and I was setting up my study, and let's pretend like my study could be answered in triangles and circles, I would set up my study to, first and foremost, flip the black circle, sort of analogy wise, right? I would flip that. I would want to try and falsify my hypothesis first and foremost. If my hypothesis withstands that test, it doesn't mean that it's right. It means that it's not wrong. And that's the best we can really do in research, is to not be wrong. So I would flip the black circle even before I flip the black triangle. If I flip the black circle and I found a black triangle, then I would flip the black triangle. And if I still found a white circle on the back of that, if I flip the black circle and I found a white triangle, then I would go to the black triangle and I would look for whether it has a white circle or a black circle. If it had a white circle on it, I wouldn't think I was right. I would say, well, I'm not wrong yet. The hypothesis is still viable. If I found a black circle, now I would know that the hypothesis had been refuted. So if I didn't refute the hypothesis with the black circle flipping, then I'd go to the black triangle and flip it. I wouldn't waste my time flipping the white circle, because all it can do is support the hypothesis, and that's not useful. It has no ability to tell me if I was wrong. In research, I think very clearly like that. In research, I deliberately attempt to falsify my hypotheses. In real life, I don't do that. In real life, I Google stuff and try and find some evidence that I'm right, right? Like any other person does, on, life-based questions. But in research, I can think very clearly and not display the confirmation bias. And that's something really that requires, the deductive reasoning to say, I'm going to reach a conclusion based on true assumptions, right? I'm going to base my conclusion in research on propositional reasoning rather than just my previous experience and my expectations about what's going to happen. So the error that we tend to make with this little demonstration, though, is what we call propositional reasoning, where we assume that if the logic flows one way, it must flow the other. And I think that's why the white circle is so attractive to people, because they're thinking, well, the white circle has to have a black triangle on the back. So I think for the average person who's making that judgment, they're thinking, well, this is having the possibility of refuting the hypothesis, because I think the hypothesis is propositional, that it's flowing both directions, when in fact it really doesn't. This particular hypothesis is only flowing one way. If there's a black triangle on one side, there's a white circle on the other. It's not, and vice versa. And so we want to draw conclusions based on true assumptions. We want to be open to the possibility that our beliefs are false, but we don't want to necessarily cause ourselves to make wrong judgments or look at the wrong evidence because we are incorrectly believing that the logic's flowing both directions, when it's really not. So that's kind of an interesting little experience, right? Here's a joke having to do with confirmation bias. The woman says, let's begin the meeting, but be aware that I am documenting all of your bullying behavior. And he says, I'm not even close to being a bully, but now your confirmation bias will make everything I say sound like bullying to you. Can you repeat the part after which you implied that I'm a delusional witch? This is a really big issue in psychology because of the tendency towards, once we have a label for someone, we see them through that lens, and everything that they do confirms our beliefs about them. And so if you were a counselor or a psychologist and you met a person who tells you, well, I've been diagnosed with this disorder, it's really hard for the clinician to not see evidence of that disorder, right? To just look for evidence that the diagnosis is correct. There are all sorts of studies that have shown that, if a person knows another person's label, they see them through the lens of that label, and they look for evidence that the label is accurate. And that's confirmation bias. Let's talk about some social judgments, confirmation bias and social judgments. I just did this demonstration on my, I thought I had changed this slide to look different. I'm going to pause you for a second. Guess not. Okay. So I just did this in my introductory psychology class, and so I'll tell you the results from that. But so this study had two different groups of people. And they both heard these descriptions of these parents that were supposed to be involved in a custody battle for their only child. Parent A was described as having average income, average health, average working hours, a reasonable rapport with the child, and a relatively stable social life. Parent B was described as having an above average income, minor health problems, lots of work-related travel, very close relationship with the child, and an extremely active social life. In the study, one group of participants was asked, who do you think should receive custody? And a different group of people were asked, which parent do you believe should be denied custody? They found that parent B in that study was the most common choice for awarding custody. The group who had heard that prompt, who should receive custody, decided parent B should receive custody. The group that heard the question, who should be denied custody, also said parent B. Parent B was seen as the most deserving of custody and also the one most deserving of being denied custody. And what happened is that the two groups were looking for anything in these descriptions to help them to make their decision. So I'm sure that the group that was deciding who to award custody said, well, the person, parent B has a very close relationship with the child, so that should be the person who has it. Plus, parent B has an above average income, so probably could afford the child more. People who were deciding who to deny probably focused on things like the minor health problems and the lots of work-related travel and the extremely active social life. Doesn't seem like the person has time for their child, so they shouldn't probably have custody. Something I would like to throw in that's kind of interesting is I just did this on my introductory psychology class. I divided them into groups and put them into breakout rooms, and they discussed the problem, and then they voted anonymously on a poll, which parent do you think? And they had been given the same prompts, right? One set of groups was asked to award and the other was asked to deny. Interestingly, my introductory psychology students made the same mistake, but they did it with parent A. They thought parent A was the most likely to deserve custody, and parent A was also the one who should be denied custody. So they made the same mistake, but the parent switched. So that's kind of interesting. I thought that was an interesting little twist in my demo. I was just trying to illustrate confirmation bias, and I was like, you went exactly the opposite of the previous research, but okay, it's the same mistake, just on the other parent. So that was kind of an interesting confirmation of the confirmation bias. And what were you focusing on? So we see this kind of confirmation bias in social judgments. We see that confirmation bias affects how we seek out information. So a group of two groups of students were asked to develop a new personality scale that would determine who is introverted and who is extroverted. And so those who were told to come up with questions that would help to determine whether classmates were extroverted generated a survey that included questions like, what would you do if you wanted to liven things up at a party? And that was, interestingly enough, they found a lot of the respondents were extroverts. With the questions that they asked, they came to the conclusion that their sample was made up of extroverts. The other members of the class were told to write a survey that would determine whether classmates were introverted or not. And they asked questions like, what factors make it really hard for you to open up to people? Well, they came to the conclusion that that same sample, who had already scored as extroverts for the other group of students, now is scoring as introverts for them. So the exact same set of students took both of these scales. They scored like extroverts on one scale and they scored like introverts on the other. It kind of indicates that the people who were instructed to develop something that would look for extroversion found extroversion. They phrased questions in such a way that it elicited extroverted responses from their classmates. Those who were looking for introverts phrased their questions in such a way that their classmates looked like introverts. It shows that we really, even when we're trying to be objective and we're really trying to find evidence or information that's, objective and accurate, confirmation bias can kind of leak in there and cause us to accidentally, inadvertently, I don't know what word I want to use, confirm what we already believe. All right, I'm going to stop here and we're going to come back in the next section and talk about framing.